Okay, so here we are to finish up on transforming functions. So as we were talking about in the previous video, the a value that we talked about, we have the negative that can go outside with a or inside with x. We have the h, which moves us left and right, and the k, which moves us up and down. So I'm just going to start in the front with the a value here, and the first thing we saw is that the a value can reflect over the x-axis if a is negative. All right, but that's not the only thing we saw. We saw that it also gave a vertical stretch. If a was greater than 1, and a vertical compression, vertical compress, we'll just call it a compress, if a was less than 1. And I need to revise that because it can not only be less than 1, but it's got to be greater than 0 as well. So a is greater than 0 but less than 1. So some sort of a fraction between 0 and 1. All right? And when I graph these, I do this from left to right. So I look at the a value, then I look at the x, then I look at the h, then I look at the k, and you'll see that as we go through the examples here. The plus and minus h, this was a horizontal shift. This was a horizontal shift. And let's see. I'm just going to say, how do we want to do this quickly and easily here? We'll just say this. We'll say h units opposite direction of the sign. Now hopefully that makes sense to you. If it doesn't, then maybe you need to write something else. But basically, if h is positive, we move left. If h is negative, we move right. Our k value over here was a vertical shift. This was our up and down shift. And this was k units in the same sign, or in the same direction, I should say, in the same direction as the sign. So if k was positive, we moved up. If k was negative, we moved down. And then we had this x that was negative up front here. All right, this was a reflect over the y-axis if negative. All right, so now we're going to take all those components and we're going to put them together. And again, my little note here, in order from left to right works best. Doesn't always have to be like that, but for me, I've just found that it works easier to do that. So again, I would encourage you at this point to turn off the video and see what you can do with these guys, all right? Okay, so I see two things on this graph. Well, actually, I see three things. Number one, I recognize that it's a parabola because of the squared, so that's going to be one of the important things. I notice it has a shift of 1 unit to the left. So we'll just say LT, and it has a stretch of 2, a vertical stretch. Okay. STRE, I learn how to spell here. There we go. STRETCH. Okay, so as soon as I shift left 1, that means that my vertex shifts left 1 also. Now my normal pattern of points for a parabola is up 1 over 1, but since there's a 2 in front, I'm going to go up 2 over 1. I'm going to stretch by a factor of 2. My next set of points would normally go up 3 over 1, but that 2 doubles the pattern, up 6 over 1. So I'm not even going to be able to graph these points. I'm well off my graph at that point. So I have that parabola right there. My next one, I'm seeing 3 things go on. I'm seeing a reflect over the x-axis, reflect. Well, I'm having a hard time here this morning. Okay, reflect over x, and then this is right 3 and up 4. So the first thing I'm going to do is I'm going to do the reflection. This is a normal absolute value. So normally an absolute value would go up 1 from the origin. And one of the things you can always do here is you can just lightly sketch these things as they happen. So I'm just going to sketch as if this was a reflection only. And so if it was a reflection only, I would have this graph that look like this. Alright? So I would have this graph here. But now I have to shift it. So I'm going to shift next. And I can shift both things at the same time. So I need to go right 3 and up 4. So I'm going to start with the vertex. That's my key point. Right 3 and up 1, 2, 3, 4. Now the nice thing about these guys is if the slope was positive 1 on the left and negative 1 on the right, then I'm going to stick with positive 1 on the left and negative 1 on the right. So I've got this graph coming down like this, and boom, it's done. It was that simple. My square root function. Again, I'm going to encourage you to graph the parent if needed. So I'm just going to start by graphing the parent square root function. So it was here, 1, 1, 4, 2. Those should be 3 key points that you should know. I'm going to roll them out to the side here very lightly so you can barely even see that. And then I'm going to take all of the y values, and what this dude is saying is multiply y's by 3. Alright, so let's look at the y values. Right here it's 0. So 0 times 3 is 0. That point stays there. The y value here is 1. 1 times 3 is 3. It jumps to here. The y value here is 2. 2 times 3 is 6. So that's 3, 4, 5. And I'm actually going to graph this one so you can see that this graph got vertically stretched by a factor of 3. Okay? So in this one we've got 4 things going on. We've got a reflection, we've got a multiple of 2, we've got a shift right 3, and a shift up 1. Again, I'm going to do this in phases. Once you get the hang of this, it'll be a lot easier, but here we go. First thing I'm going to do is I'm going to start off, but this time I'm going to use my square root function from the previous one, and I'm going to reflect it. I'm not going to stretch it yet, I'm just going to reflect it. Okay? Or, better yet, let's do this. Since I've already got it graphed over here, let's just multiply the y values by negative 2. My first y value is 0. Multiplying it leaves it at 0. My second y value is 1. Multiplying it by negative 2 drops it to negative 2. My third y value is 2. Multiplying it by negative 2 brings it to negative 4. So take a look at that graph. Okay? Now, you don't even have to draw this if you don't want to, but here's what I've got going here so far. Now I need to shift it to the right 3 and up 1. Alright, so let's do that. I'm going to start with my first point to the right 3 and up 1. My next point to the right 3 and up 1. And my last point to the right 3. And I'm just going to estimate and up 1. There's my transformed graph, just like that. Alright? Alright, so now we have a parabola again. This is 1/4 x squared plus 5. Now this one again, I'm going to start out by graphing the parent function just so you can see what's going on again. So my parent function parabola looks like this. Here we go. Alright, so I'm not going to draw this time or it's going to get a little bit ugly here. So I need to multiply all of the y values by 1/4, or excuse me, negative 1/4. So this is a vertical compression with the 1/4 and a reflection. 0, 0 doesn't move. So it's going to stay at 0, 0. Get my pen lights. Oops, wrong color there. Alright, so 0, 0 doesn't move. Now, my next y value is at 1, and I want to multiply that by negative 1/4. 1 times negative 1/4 is negative 1/4. Check out where these guys end up. They end up on the other side of the x-axis, which is exactly where they should be. My next 2 points were at 4. Multiplying 4 by negative 1/4 puts them both at negative 1. So take a look at this parabola. It almost looks like an absolute value, but it's not. It's got to have a curve in it. But look at how wide this thing is. A lot wider than the parent function. So it's got a vertical compress, a flip over the x-axis, and now we need a shift up 5 units. So I need to move all of those points up 5 units. 1, 2, 3, 4, 5. My 2 values a 1/4 unit down, and my other 2 values 1 unit down. There's my finished product right there. Okay, next one. This is an absolute value that's been stretched by a factor of 2 and then dropped down 5 units. Now, here's the nice thing about absolute value. The 2 represents slope. And the vertex of this guy is 0, negative 5. So I'm not even going to do the parent function. I'm going to drop to 0, negative 5. And I'm going to use my slope. When I say slope, remember absolute value has 1 positive and 1 negative. Alright, so the slope on the right side is going to be positive 2. The slope on the left side is going to be negative 2. That one's done. That was easy, wasn't it? Absolute values are super simple. Next one, square root function that's been multiplied by negative 1/2 and then dropped 1. So I'm going to go back and use my graph up above to help me out here. So there's my parent function in red, and I need to flip it, and I need to compress it by 1/2. So let's do this. Let's take our negative 1/2 right here in front and multiply it by the 3 y values. So 0 times negative 1/2 is going to be 0. 1 times negative 1/2 is going to be negative 1/2. And 2 times negative 1/2 is going to be negative 1. Alright? Now this time I'm not going to drop because I still need to drop at 1 full unit. So I'm going to go down and I'm going to drop everything 1 unit here, 1 unit here, and 1 unit here. And this would be my finished product. Alright? Same thing with the next one. I know that this thing has to start at negative 1, negative 4. Now we're going to try and do this based on that. Negative 1, negative 1, 2, 3, 4. So there's my starting point. Okay? Now, I'm supposed to multiply everything by 2. So if you look at the points here up on, again, on letter, some of my numbers are off here. Okay? So if you look at this graph up here on top, right here again, all right? Using this graph as a pattern, my next point normally goes up 1 and over 1. Because of the 2 in front, it's going to go up 2 and over 1. All right? My next point normally goes, again, up 1 and over 3. So this time we're going to go up 2 and over 3. And we're going to draw our graph. figure it out. Once you get those pattern of points down, it's a piece of cake.